In this video, I will talk about semiconductors. It's pretty easy. Semiconductors are just components that have a conductivity that is as half as good as the normal components. What are you even thinking? Semi-components are just components like a diode or a LED that can pass current only in one way. If I'm not a lazy faggot, normally there should appear a picture of a diode and a LED next to me. But now let's move on to the theoretical part. So fellas, we have three different ways how to draw a diode in schematics. The first one is just an empty triangular. The second one is the same triangular but with the line goes through the triangular. And the third one is with a solid triangular. They have all one thing in common, and that is the direction where the triangular is pointing at. It's always pointing to the right. That means that the current can flow from left to right. So that means the highest polarity have to be on the left and the lowest one on the right side. If we draw a schematic with a supply of 10 volts, the upper one is plus, the other one is minus. I connect a resistor of 50 ohms and a diode. So this schematic will only work if the diode has a voltage of 1.6 volts across it. 0.6 volts. Okay, that means that the supply has to give 0.6 volts to the diode and has only 9.4 volts left for the resistor. Now the question is, how much current does flow in this circuit? Now let's say that this diode is perfect, like there's no voltage drop in the diode. So if you see the current is equal to the voltage divided by resistance, this means 9.4 volts divided by 50 ohms. Dividing by 50 is the same as dividing by 100 and then multiply it with 2. So if we divide this by 100, it's equal to this times 2, 20, and this equals 0.188 amps or 188 milliamps. But what happens when the diode switches or flips? Let's change my schematic. So I flip the diode like this. Now we didn't flip supply voltage, so the current will all flow in this direction. But it is in the wrong direction for our diode. So, like I said here, there will be no current flowing. Now the diode acts like an open circuit. If I redraw this part, it will look like this, and here was the diode. Or we can draw a resistor with infinity ohms. Well, there's a kind of rule for circuits in series, like the higher the resistance is or resistor, the more voltage it needs. So, like I said, this is equal to a resistor with infinity ohms. We can say that the total voltage of this supply will be across here. If you attach a voltmeter like this voltmeter on the display, you will see 10 volts. If I say diodes to you, you will also think about the LED or LED. The L stands for light, the E for emitting, and the D for diode. So it works the same as a normal diode, but this one emits light. Like we have a red diode, red LED LED, a blue LED, green LED, and so on. But the voltage across it is different than the normal LED. First, I will show you the schematics, or how we draw it in a schematic. It looks pretty much the same as a normal diode, but the difference now is there will be arrows at the top of each diode, which shows the light it's emitting. If I'm not a lazy cunt, I should show you the graph for LEDs, their voltage and current. Now we're always talking about connecting a diode with a DC or the direct current supply, but what happens when we attach it or connect it with a AC supply? AC, let's say it's 10 volts, peak to peak. We connect the resistor, the same resistor, 50 ohms, and the diode over here. Okay, first I will draw or try to draw the voltage that comes out of our voltage supply. This is time, this is the voltage source, the S. Don't judge, I'm not a drawing expert. Looks pretty good. Okay, so this voltage comes out of our voltage supply, peak to peak, 10 volts, so from this point to there must be 5 volts. Okay, let's say if it's positive, the current goes in this direction. When it's negative, the current flows in that direction, or should flow in that direction. Okay, let's check the voltage across our diode. Again, the time, and this is the voltage for our diode VD. The voltage for the diode, again, it needs 0.6 volts to work efficient. So the voltage over the diode will rise till it reaches 0.6 volts. Then the curve will be flat until our supply reaches again 0.6 volts, then it will drop to 0. That's at this point. Like that. But now the polarity switches, so the current won't flow in that direction but wants to flow in this direction. What happens if the current wants to flow in this direction? The diode acts like an open circuit, so there will be no current flowing, but all the voltage of the supply will be across the diode. So from this point is that point, this point, like this, and all the voltage from the supply is across this diode. And again, when it's positive, it will reach to 0.6 volts, will be flat, then again to 0. And then it repeats itself. That's the voltage for the diode. But what about the current? So it's again in the time, the I for current, and the D for diode. For the current, there will be only current flowing when the diode is working, So when the diode has 0.6 volts, then the current will be maximum, and again 0.6 volt is around this point, I think. Yeah. So the current will be rising, but the current will exactly follow the curve of the supply voltage. So it will be to the top and then end at this point, because we reach 0.6 volts, it's 0, and then the voltage is reversed, so there will be no current flowing until here, the 0.6 voltage, like that. Again, I'm not a drawing expert, but I try my best, and it will repeat itself. But what happens when we compare the theoretical diode with the practical diode? Let's draw another curve, especially for our diode. This is the voltage of our diode. This is the current that will flow from our diode. I should name it differently. I want this to be the voltage, and this is the current. It will be more easy. This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. If our diode is theoretical perfect, so nothing is wrong and it works perfectly, this will happen. Nothing will happen until we reach 0.6 volts, and then BAM! The diode is conductive. Let's say we add a reverse voltage, but I will larger scale, like 10 volts, 100 volts, 1000 volts, and so on. If it's theoretical perfect, nothing will happen. There will be no current flowing. But what if we compare this with a practical one? A practical one, again, we start from 0 and we go up till we reach 0.6. But you see, the current will be rising just here, but only just a little bit. There are a few milliamps, nanoamps, like a very small current. But the current will be larger and larger and larger the higher voltage you give to the diode. But when you reverse the polarity, like you go in this side of the curve or the graph, this will happen. That's totally different than the theoretical one. What happens here? Around, let's say, it depends on the type and the module of the diode, but on average it's around 600, 800. That's the voltage, that's the current that the diode will be collapsing, it will be broken. Then the diode won't act like an open circuit, but will act like a closed circuit. Just like a switch. This is the normal. This happens in this area, but then the voltage is too high and the diode collapses, it breaks. The circuit, the switch will close, or the diode will act like a closed circuit, and it's like a short. This happens in this area.